the era of Dragon has become more brilliant than anyone ever imagined. Once viewed as the younger sibling of NASA's Space Shuttle and the Russian Soyuz, it has now emerged as something more powerful, more versatile, and more symbolic than either of its legendary predecessors. Dragon didn't just meet expectations, it shattered them. It became a gleaming flagship for a new age of private spaceflight, ushering in a reality where humans weren't limited by the sluggish pace of government missions but propelled by the relentless momentum of innovation. But just as this shining era was reaching its peak, something unexpected happened. The spacecraft that symbolized hope and progress now teeters on the edge of extinction, not due to a mechanical flaw or a catastrophic failure, but because of political tensions that have spiraled into something far more dangerous than gravity: uncertainty. A growing wave of unease has begun to ripple through the international space community. Once enthusiastic engineers, scientists, and researchers are now gripped by concern. Whispers of canceled plans, halted experiments, and derailed missions are circulating like static in a mission control room. There is a genuine fear that Dragon, this emblem of progress and possibility, could be reduced to a museum piece. And with its potential demise, the Russian Soyuz spacecraft would regain its monopoly over transporting astronauts and cargo to the International Space Station. In that chilling scenario, years of progress would be undone. The optimism that defined a generation of private space exploration could be swept away in a tide of political fallout. So what exactly happened? What forced Elon Musk to make such a shocking declaration about Dragon's future? And if the Dragon fleet is scrapped, what does that mean for NASA, for Starship, and for the future of human presence in space? To understand this moment, we need to rewind just slightly. Elon Musk had just completed a brief but notable stint as a special government employee at the newly formed Department of Government Efficiency, known simply as the DOG. It was an unusual but highly publicized role, one that drew praise from President Donald Trump, who repeatedly applauded Musk's contributions during this tenure. It seemed, at first, like a partnership made in the stars, two powerful figures aligned on the future of American innovation and dominance. But then, without warning, the alliance fractured. What began as a disagreement over a piece of legislation quickly spiraled into a very public feud. Trump's so-called Big Beautiful Bill, a sweeping government spending package, drew harsh criticism from Musk. On X, formerly Twitter, Musk posted a fiery statement, calling the bill an outrageous pork-filled congressional monstrosity, labeling it a disgusting abomination, and shaming those who voted in favor of it. "You know you did wrong," he wrote. It was a message that rang out across the digital world. Trump, visibly angered, responded in an Oval Office press briefing alongside German Chancellor Friedrich Merz, expressing disappointment. "Elon and I had a great relationship," he said with a tone that hinted at finality. "We don't know if we will ever again." The disagreement exploded into an all-out clash. Musk accused Trump of being ungrateful, asserting that without his support, Trump wouldn't stand a chance of reclaiming the presidency. Trump retaliated with a direct financial threat, suggesting that the U.S. government could save billions of dollars simply by cutting all subsidies and contracts tied to Musk's companies. "We were always surprised Biden didn't do it," Trump posted on Truth Social. That line sent shockwaves through not just political spheres but through the aerospace industry itself. Musk, in turn, issued a threat of his own, one that would have seismic consequences for NASA. In a bombshell post, Musk stated that SpaceX would begin decommissioning its Dragon spacecraft immediately in light of the president's comments. The statement sent the space world into a tailspin. Could this actually happen? Could SpaceX, NASA's most reliable partner for transporting astronauts and supplies to the International Space Station, just pull the plug on its most proven spacecraft? Thankfully, hours later, Musk responded to a user post with a small concession. "Okay, we won't decommission Dragon," he replied. But it didn't feel like a full retraction. The tone was exhausted, wounded, and bitter. You could almost feel the weight behind those words. It seemed as though Musk had made up his mind, not to cancel Dragon just yet, but to step back emotionally from what had once been a passion project. And that, in its own way, is equally alarming. Dragon is more than a spaceship. It's a symbol of what private innovation can achieve. Since its debut flight in 2010, the spacecraft has proven itself over and over again. It was the first private vehicle to carry cargo to the ISS, and later the first private vehicle to carry astronauts. Its reusability has allowed NASA to operate more affordably and frequently, slashing the cost of missions that used to require billions of taxpayer dollars. But perhaps most importantly, Dragon severed NASA's dangerous dependence on Russia's Soyuz spacecraft, a reliance that had, for years, left America in a vulnerable position. In the post-space shuttle era, Dragon didn't just fill a gap. It opened a door. It showed that the United States could lead again, not just in scale or ambition but in practical, sustained access to space. The recent success of missions like Polaris Dawn and the second Axiom commercial mission, FRAM-2, only reinforced that narrative. Every successful Dragon flight felt like a heartbeat in a living, breathing space program. And now, all of that stands at risk of being undone. Not because the vehicle failed but because the political ground beneath it is cracking. If Dragon were actually eliminated, NASA would face an existential crisis. It would lose its most trusted partner in orbit. Its schedule of launches would collapse. Experiments aboard the ISS could be indefinitely delayed or cancelled. Entire programs would need to be restructured. And the message it would send to the global community would be devastating, that America's private space industry, its crown jewel, is no longer stable. In that scenario, the door is wide open for rivals like China and Russia to race ahead. The damage wouldn't just be technical. It would be reputational. It would be strategic. For now, we've dodged that bullet. Musk has confirmed that Dragon will remain operational, but the ground feels shaky. Political tensions haven't gone away. If they rise again, and let's be honest, with the upcoming election and volatile personalities involved, that's almost a certainty. What's to stop another crisis from surfacing? Could Musk be pressured again into abandoning Dragon? Would SpaceX's contracts with NASA even allow for such a sudden pullout? Or is there some quiet clause, some bureaucratic backdoor that could lead to Dragon's demise without anyone seeing it coming? NASA, to its credit, has tried to hedge its bets. The space agency always planned to avoid over-reliance on a single provider, which is why Boeing's Starliner spacecraft was funded in tandem with SpaceX's Dragon under the Commercial Crew Program. But while Dragon has soared, Starliner has stumbled. The contrast between the two couldn't be more stark. While Dragon has made 46 successful visits to the ISS, Boeing has only attempted 3 flights with Starliner, 2 of them plagued with technical issues, and 1 crewed flight in 2024 that was ultimately deemed a failure. Despite this shaky track record, NASA hasn't given up on Starliner. Officials recently briefed reporters about the spacecraft's future, revealing that the next launch could happen as early as the first quarter of 2026. Whether that launch will carry astronauts or only cargo remains unclear. Between now and then, NASA and Boeing face a monumental task, conducting a rigorous battery of tests, resolving technical failures and preparing astronauts for a potential post-certification Starliner mission. But none of that is guaranteed. And in the shadow of Dragon's success, Starliner still looks like a distant second. If Dragon were to disappear, and Starliner wasn't ready to take its place, then what? Does America return to relying on Russia? Do we abandon long-term ISS commitments? Or do we simply pause and watch as others take the lead? Starliner consists of a reusable crew capsule and an expendable service module that, in theory, can carry up to 7 astronauts into orbit. It was supposed to be Boeing's answer to Crew Dragon, an equal rival in a new golden age of American human spaceflight. Back in 2014, NASA gave Boeing a fixed-price contract worth $4.2 billion to design, build, and operate the spacecraft. SpaceX, by comparison, was awarded $2.6 billion for its Dragon vehicle. Despite the larger funding and Boeing's legacy in aerospace, as of early 2025, Starliner was at least $2 billion over budget. A painful irony, especially given that Dragon has already flown dozens of successful missions, while Boeing's effort has staggered forward with delay after delay, problem after problem. Originally intended to take its first astronauts to space in 2017, Starliner's journey has been anything but smooth. Technical issues, ranging from software glitches to faulty valves, kept the capsule grounded for years. When its first unmanned test flight finally launched in 2019, it failed to reach the International Space Station due to a mission clock error that caused it to burn too much fuel. That flight was declared a partial failure. Another attempt in 2022 did reach the ISS, but still raised concerns. It wasn't until June 2024 that Boeing finally launched its first crewed flight. But even that long-awaited milestone was marred by setbacks. The spacecraft suffered repeated delays while sitting on the launch pad, each caused by recurring technical problems. And when it finally blasted off on June 5, 2024, hope turned to anxiety. A helium leak during the flight caused the astronauts to float untethered in a disconcerting moment that lasted nearly an hour. It was a haunting scene, 2 highly trained astronauts, suspended in a metallic capsule, moving helplessly while mission control worked feverishly to stabilize the situation. Eventually, Starliner did manage to dock with the ISS, but not without losing 4 of its 8 aft-facing reaction control system thrusters. This was not how a flagship NASA spacecraft was supposed to perform. NASA had framed Starliner's first crewed flight as a pivotal moment, one that would validate a decade of work and justify billions in taxpayer investment. Instead, it turned into a cautionary tale. The astronauts, courageous, collected, and professional, later described the incident as precarious. Since that troubled flight, Starliner has been stuck in limbo. NASA and Boeing have conducted post-mission reviews, but progress has been glacial. A member of NASA's Aerospace Safety Advisory Panel recently admitted that while anomaly observations were complete, the root cause remained elusive. The spacecraft's future was uncertain. In fact, Boeing's own financial filings painted a grim picture. Their latest 10-K report revealed that the Starliner program lost $523 million in 2024 alone, $125 million in the second quarter, and a jaw-dropping $250 million in the third. Losses from the first and fourth quarters haven't even been disclosed yet. In total, the program's cumulative losses have ballooned to more than $2 billion. With so much uncertainty, it's difficult to see how Starliner could realistically shoulder the burden of replacing Dragon, let alone exceeding it. Meanwhile, NASA has looked to other companies for alternatives. One of the most promising is Sierra Space, whose Dream Chaser vehicle is essentially a mini space shuttle. Unlike the capsules favored by SpaceX and Boeing, Dream Chaser is a winged spacecraft that launches vertically but glides back to Earth on a runway like a conventional airplane. It's an elegant concept, merging the best of old and new technology. The spacecraft, named Tenacity, is currently in final preparations for its maiden flight. Dream Chaser's DC-100 cargo variant boasts a robust set of technical features. It's equipped with over 2,000 heat shield tiles made from materials stronger and more durable than those used on NASA's original space shuttle, yet still composed largely of heat-resistant silica. The result is a vehicle that can endure the intense heat of re-entry with minimal damage, allowing for quick turnaround times between missions. Tenacity is designed to carry up to 11,500 pounds of cargo to orbit and bring up to 3,500 pounds back down. Once docked to the ISS, it can remain attached for 45 days before autonomously undocking and gliding back to Earth. Importantly, Dream Chaser doesn't require ocean splashdowns or recovery ships. It lands on runways at NASA's Kennedy Space Center, reducing complexity, cost, and risk. Its fast launch prep, just 24 hours, is a game-changer. This gives it the potential to become a reliable workhorse for low Earth orbit missions. Though its first launch was initially slated for early 2025, it has since been delayed. No new launch date has been confirmed yet, but current estimates suggest it could fly sometime in the third quarter of this year. If Dream Chaser proves successful, it may become a strong contender in NASA's Commercial Resupply Services (CRS) program and eventually in commercial crew. But all these developments, impressive as they are, seem to pale when weighed against the monumental promise, and equally monumental risk, of SpaceX's Starship. Starship is not just another rocket. It is a complete revolution in space access. The system, composed of the Starship upper stage and the Super Heavy booster, is designed for full reusability. If perfected, it could reduce launch costs by orders of magnitude, opening the door to sustain lunar missions, Mars colonization, and space industrialization. NASA has already invested $4 billion in Starship development, with the hope that it will serve as the human landing system for Artemis 3, the mission that will return astronauts to the Moon for the first time since Apollo 17. The tentative target date for Artemis 3 is mid-2027. So far, Starship has completed 9 test flights, gradually improving with each iteration. The latest test demonstrated dramatic advancements in stage separation, re-entry control, and booster recovery maneuvers. Flight 10 is expected within the next 3 to 4 weeks and will further test the system's reliability. But the specter of politics looms over everything. During the Biden administration, regulatory disputes with the FAA caused lengthy delays between Starship flights. And now, with Elon Musk's increasingly public feud with President Trump, there's reason to worry that the program could once again become entangled in political crossfire. Imagine if Starship's 10th flight were delayed not by technical challenges, but by government bureaucracy. Imagine if a permit was withheld or funding was frozen, or support staff pulled from the project. The momentum would falter. A program that is already pushing the boundaries of engineering would face an entirely different type of resistance, one rooted not in science but in strategy and power. That's a scenario we can't afford. Because Starship is more than just a project. It's a vision for the future. It promises to carry more than 100 people per flight, far beyond Dragon's limit of 7. Its vast payload capacity could enable the construction of entire space stations in orbit, the deployment of massive telescopes, and the delivery of equipment to build habitats on the Moon and Mars. It's the linchpin of Musk's dream to make humanity a multi-planetary species. And yet, for all its ambition, Starship depends on the continued functionality of the systems that came before it, namely Falcon 9 and Dragon. The transition from Falcon to Starship will take time. Infrastructure must be upgraded. Payloads and operations must be adapted. Crew training must evolve. Until Starship is fully certified and routinely operational, Dragon remains essential, not just as a backup, but as the backbone of America's access to orbit. Fortunately, Musk seems to understand this. Despite the heat of his confrontation with the president, he has walked back his threat to retire Dragon. The Axe-4 mission, which will send 4 astronauts to the ISS aboard a Crew Dragon capsule, is moving ahead. That's not a coincidence. It's a clear message to NASA, to the public, and perhaps to Washington. SpaceX will not abandon its responsibilities, no matter how messy the politics get. And we should be grateful for that. Because in the coming years, the race for space supremacy will only intensify. China's Tiangong space station is growing rapidly. Russia is planning its own orbital outpost and lunar missions. India and Japan are investing heavily in robotic exploration. The global competition is real, and if America falters, if we allow politics to strangle innovation, we risk ceding our leadership in space at the very moment it matters most. This is not just about national pride or technological prestige. It's about the future of science, security, and humanity itself. The International Space Station is a beacon of cooperation, but it's aging. Its replacement must be bold, robust, and capable of supporting long-term human habitation. NASA's Artemis program is our ticket back to the Moon and eventually to Mars. If Starship fails, that ticket could be revoked. And so, as we stand at this precarious juncture, we must remember that progress is fragile. It requires unity, patience, and above all, vision. Elon Musk may be a polarizing figure, but his contributions to spaceflight are undeniable. The Dragon era has brought us unprecedented access to orbit, and the Starship era could take us far beyond. But none of this will happen by accident. It requires leadership, not just from Musk but from our elected officials. It requires steady hands at NASA, resilient engineers at SpaceX, and public support that does not waver when headlines turn sour. We must reject short-term politics and embrace long-term purpose. We must protect the programs that work, invest in those that promise, and hold accountable those that falter. Dragon is still flying. Starship is still climbing. And as long as we keep looking up, not back, we might just reach the stars after all. Stay with us for more updates as this historic chapter unfolds.